Greetings. I am Inigo V. Montoya and I am from BS Mechanical Engineering program. Today I'm going to tackle about apportionment Hamilton's method. So this picture is Alexander Hamilton, the one who proposed the Hamilton's method. So our objectives in this video is to define Hamilton's method, and number two is to be able to apply Hamilton's method. So introduction. The term democracy originates from the Greek words demos, signifying people, and kratos, denoting power. In a democratic framework, inclusivity is crucial, ensuring every voice finds expression. Yet, when a finite number of positions exist in the House of Representatives, a just allotment becomes necessary to factor in state dimensions and population size. Apportionment, on the other hand, is a mechanism through which voting seats are divided and assigned to each state under representation. Each process guarantees that even states with smaller populations can receive equitable representation and have their perspective acknowledged. So in a democratic country like the United States, apportionment is crucial in order to have equal representatives among the states of the country. In certain cases, every state has been allocated a specific count of voting seats, leaving a small number of surplus seats unassigned in the House of Representatives. As it's unfeasible for each state to acquire an additional seat, a systematic approach becomes necessary to identify the states deserving of the extra seats in the year 1792. After the first United States Consensus in 1790, a need arose to apportion the number of representative seats. After much debate, founding father Alexander Hamilton proposed an apportionment method in 1792. This method, known as Hamilton's method of apportionment, would fairly distribute the number of representative seats according to the population quota of each state. This method accounting for instances where the House of Representatives may have additional unfilled voting seats. By using the Hamilton's method, these unfilled seats can be fairly distributed to the states with the greatest quota. So in order to understand Hamilton's method, we're going to dig deeper through different 5 examples which utilizes the method. So in implementing the Hamilton's method, there are 4 steps. Step 1, determine how many people each representative should represent. Do this by dividing the total population of all the states by the total number of representatives. This answer is called the standard deviation or standard divisor. Step 2, divide each state's population by the divisor to determine how many representatives it should have. Record this answer to several decimal places. This answer is called the quota. Step number 3, cut off the decimal parts of all the quotas. These are called lower quotas. Then we add the lower quotas. This sum will always be less than or equal to the total number of representatives. Step 4, assuming that the total from step 3 was less than the total number of representatives, assign the remaining representative, one each to the states whose decimal parts of the quota were largest until the desired total is reached. To implement this method, we're going to have an example. Example number 1. Consider a country with 4 states and 30 seats in Congress and population distributed as in the table below. So in our slide before, step 1 is we need to determine how many people each representative should represent. Do this by dividing the total population of all the states by the total number of seats. This answer is called the divisor. So in state 1, we have 27,500 population, state 2, 38,300, state 3, 46,500, state 4, 76,700. In total of 189,000 population. So in step 1, we need to divide the overall population to the overall all the seats in the Congress. So 89,000 population divided by 30 seats, we'll get the answer of 6,300. So this will be our divisor. Step 2. Divide each state's population with a divisor to determine how many representatives it should have. Record this answer to several decimal places we call it quota. So our divisor is earlier is 6,300. So we need to divide the population to our divisor. So our population 27,500 divided by the quota divided by the divisor 6,300 will get the answer 4.3651. In state 2, the same process, we'll get 6.0794, state 3, 7.3016, and state 4, which is 12.1746. Step 3, we cut off the decimal parts of all the quotas. These are called the lower quotas. Then we add the lower quotas. This sum will always be less than or equal to the total number of representatives. So, need to cut the lower quotas. So, in state 1, the lower quota is 0.3651. So we need to ignore the lower quotas and put the upper. So we need to ignore the lower quotas and put our initial number of representatives in the first before decimal part of our quota. So we got 4 in state 1, state 2, in state 2 we got 6, state 3 we got 7, and state 4 we got 12. So the sum will always be less than or equal to the total number of representatives. So in this example, we get the total initial representatives in each state equal to 29, and our seats is equal to 30. So in order to allocate the remaining 1 seat to our representative, we need to apply the step 4. Assuming that the total from step 3 was less than the total number of representatives, assign the remaining representative 1 each to the states whose decimal parts of the quota were largest until the desired total is reached. So as we can see in a quota, the largest decimal value here is 3.3651 in state 1. So we need, compared to other quotas, it is the largest decimal value. So we need to allocate the remaining 1 seat to the state 1 since it has the largest decimal value. So our initial representative of 4 will be added to 1, we'll get the final representative of 5. State 2 will get 6. State 3 will get 7 seats, and state 4 we got 12 seats. So this is a result of 30 seats for representatives of each 4 states. So we need to, in order to understand more, we need to delve into another example. Example number 2. Assuming that a country is divided into 3 regions with 10 allotted seats in the parliament using Hamilton's method. Step 1. Determine how many people each representative should represent. Do this by dividing the total population of all regions by the total number of seats. This answer is called a divisor. So we need to repeat our process. Our population for region 1 is 40,000, region 2 30,000, and region 3 is equal to 30,000. A total of 90,000. So we need to allot 10 seats to each region. So our divisor is equal to the total population over the seats. So 90,000 population over 10 seats will give us the answer of 9,000, and this will be our divisor. So in order to get the quota, again we need to divide our population to the divisor, which is 9,000. 40,000 divided by 9,000 will give us the answer 4.444. In region 2 we got 3.333, and in the region 3 we got 2.222. In step 3 we cut off again the decimal parts of all the quotas. So we need to cut off the decimal part and put our initial number of representatives to each region. So we got 4, we got 3, we got 2, and this will be total of 9 representatives. So in step 4, we need to, there are 10 seats allotted. So there are only 9 in our initial representative total. So we need to allocate one remaining seat to a specific region. So we need to find the region who has the largest decimal value. In here, we get region 1, which is 0.444, which is the largest decimal value in 3 regions. So we need to allocate the remaining 1 seat to region 1. So we get the initial 4 plus 1, we get the final 5. Region 2, we get 3 seats, and region 3, we got 2 seats. In total of 10 seats. This is the result for the allotment 10 seats for the representative of each 3 states. For our next example number 3. There is a science enthusiast club in a school, and they want to allocate 5 committee seats among 3 different grades: freshmen, sophomores, and juniors. In here, we see that Hamilton's method can also be used in different types of scenarios in our daily lives. So again, in step 1, we need to divide our total population to the allotted seats. So we get population of freshmen, which is 60, sophomores 40, and 50, in total of 150. So in order to get our divisor, again, we need to divide our total population to 5 seats. So our divisor will be 30. In step 2, we need to divide again our divisor and divide our population to our divisor, which is 30. 60 divided 30 will give us 2. 40 divided 30 will give us 1.33, and 6 divided by 30 will give us 1.66. In the next step, we need to count up the decimal parts again. So in freshmen, there are no decimal parts, so we need to just put the 2 as is. So sophomores, we need to ignore our decimal part 0.333 and put 1, and ignore the 0.66 and put 1. That will give us the answer of 4 total representatives. So we need to allocate 1 missing representative seats in each grade level. In step 4, we need to add the remaining 1 seat to our largest decimal value, which is the juniors, 0.666. So in our final allocated representatives, in freshmen we got 2 seats, sophomore 1 seat, and juniors plus 1 seat will give us 2 seats. So this is the result for the allotment of 5 seats for the representative of each 3 different grade levels in the pool. So in our next example number 4, let's use Hamilton's method to allocate a fixed budget among a group of friends for a weekend trip. In this scenario, you have a group of 5 friends and you want to divide a total budget of 10,000 pesos. Among them, fairly based on their preferences, find the divisor quota for Jane and her final apportionment. So we need to list the budgets for each friends. So Jane had 3,000 pesos, Mark got 2,000 pesos, and Charles had 5,000 pesos, Mary got 1,500, and Christian got 1,500. In total of 9,500. So we need to allocate the remaining 500 pesos to each of these people. So in step 1, again, we need to find our divisor, which is the total population, total budget over the total allotted budget. Will give us the answer of divisor, which is equal to 0.95. So in step 2, we need to divide our budget to our divisor, which is 0.95. 3,000 divided by 0.95 will give us the answer of 3,657.895. Mark will give us 2.105.26. In Charles, we will have 1,578.94. In Mary, we got 1,578.94. In Christian, we got 1,578.9474. In total of 9,500. So the next Next step. So in the next step, we need to ignore the decimal value. In initial, we get 3,000. Mark will give us 2,000. Charles will give us 1,500. Mary will give us 1,500. And Christian will have 1,500. A total of 9,500. So in step 4, we need to identify the largest decimal value, and we'll give the remaining 500 pesos to an individual who has the largest decimal value. So in here, we've got the highest total value, decimal value of 0.895 by J. So we need to allocate the remaining 500 pesos to J, which will give us the final budget for J will give us 3,500. Mark will give us 2,000. Charles will give us 1,500. Mary will have 1,500. And Christian will have 1,500, a total of 10,000 pesos. So in the problem below, we need to resolve around the budget for each friend. To answer the question, our divisor is equal to 0.95. The quota for J is equal to 3,657.895, and her final apportionment will be 3,500. Example 5, a teacher wishes to distribute 10 identical pieces of candy among 4 students based on how many pages of book they read last month. Using Hamilton's method, the table below lists the total number of pages read by each student. So Ryan read 500 pages, Miles read 230 pages, Harvey read 180 pages, and Zil read 130 pages, a total of 1,040 pages. So to answer the following question, we need to find the divisor, find the quota for Carty, and find the initial apportionment for Zil. In step 1, we need to find our divisor. Our 1,120 pages will divide into 10 candies to give us the answer of 412. In step 2, divide each pages of student. Divide the pages read by the student to our divisor, which is 112. Ryan will have 5.1786, and Miles will get 2.0536, and Carty will get 1.6071, and Zil will get 1.1607. So in step 3, we need to cut off the decimal parts. So in Ryan, we have the initial number of 5 candies, and Miles will have 2 candies, and Carty will have 1 candy. Zil will get 1 candy, a total of 9 candies. So we need to allocate the remaining 1 candy to the student who has the largest decimal value. So in step 4, we need to allocate the remaining 1 candy to the largest decimal number, and the largest decimal number here we have is Carty with 0.6071 decimal value. So we need to allocate the remaining 1 candy to Carty, and will give us the answer of 2. So our final candies for each student will have 5 for Ryan. Miles will have 2 candies, 2 candies for Carty, 1 candy for Zil, a total of 10 candies. So our divisor is 112. Find the quota for Carty, which is 1.6071, and the initial apportionment for Zil is 1 candy. So that's it for Apportionment Hamilton's method. I am Calvin Montoya, and that's my explanation on my topic.